Helm in DevOps, a practical guide. Chapter 1. Introduction to Helm and its role in DevOps. In the evolving world of DevOps, container orchestration has become a critical part of managing modern cloud-native applications. At the center of this ecosystem, Kubernetes reigns as the de facto standard for orchestrating containers, and Helm, often described as the package manager for Kubernetes, has emerged as an indispensable tool for simplifying Kubernetes deployments. This book is your comprehensive guide to understanding and mastering Helm, tailored for DevOps professionals who want to streamline and automate their Kubernetes workloads. We'll cover everything from the basics of Helm to its advanced usage in CI/CD pipelines, and along the way, demonstrate how it can help you achieve scalable, efficient, and resilient software delivery. Whether you're an engineer just getting started with Kubernetes or a seasoned DevOps professional looking to fine-tune your deployment strategies, this book is designed to help you unlock the full potential of Helm in your day-to-day workflows. Chapter 2. The Basics of Helm. To understand the true value of Helm, it's important to first grasp its core components. At its heart, Helm is a tool designed to manage Kubernetes applications using a system of charts and releases. Helm charts. A Helm chart is essentially a template that defines a Kubernetes application. It contains all the resource definitions required to run an app, including pods, services, deployments, and more. These templates allow for reusable configurations, enabling you to quickly deploy similar applications across environments. Helm releases. Every time you deploy a Helm chart, you create a release. A release represents an instance of a chart running on your Kubernetes cluster, allowing you to manage updates, rollbacks, and upgrades with ease. In essence, Helm abstracts away the complexity of deploying applications to Kubernetes by managing the underlying YAML files and dependencies for you. Chapter 3. Installing and configuring Helm. Before you can start using Helm, you need to install and configure it properly. Helm works by connecting to your Kubernetes cluster using kubectl under the hood. Here's how you get started. 1. Install Helm. Helm can be installed using package managers like Homebrew for Mac OS, or simply by downloading the binary for your operating system. 2. Setting up Helm in Kubernetes. Once Helm is installed, you'll need to configure Helm to work with your Kubernetes cluster. This usually involves setting up a service account and ensuring proper access controls. With Helm 3, the process has become much more straightforward as it no longer requires a server-side component known as tiller, which was used in Helm 2. 3. Using Helm commands. Helm commands are fairly simple. You can search for charts using Helm search, install them with Helm install, and upgrade them with Helm upgrade. In this chapter, we'll walk through common Helm operations and the lifecycle of a Helm release, from installation to deletion. Chapter 4. Building Helm charts. The true power of Helm lies in creating custom Helm charts for your own applications. Helm allows you to structure your Kubernetes resources into a chart that can be easily deployed and shared across teams. This chapter focuses on the anatomy of a Helm chart. Chart.yaml. The metadata for your chart, including the version and description. Values.yaml. A default configuration file that contains the values you can override at the time of deployment. Templates directory. The Kubernetes resource templates are defined here. Helm uses the Go templating language to inject values from values.yaml or any user-specified overrides into these templates, making it flexible to create dynamic configurations. Chapter 5. Helm in CI/CD pipelines. In a DevOps environment, continuous integration and continuous deployment, CI/CD, pipelines are essential for delivering software efficiently. Helm integrates smoothly into these pipelines, enabling automated deployments of your Kubernetes applications. Helm in Jenkins pipelines. Integrating Helm into a Jenkins pipeline for deploying Kubernetes applications as part of an automated CI/CD workflow. GitOps with Helm. Using Git as the source of truth for Kubernetes cluster state, with Helm providing the deployment mechanism in tools like Argo CD or Flux. Helm secrets and secure deployments. Managing sensitive information in a secure way using Helm and tools like Helm Secrets or Sealed Secrets. By incorporating Helm into your CI/CD pipelines, you can achieve automated deployments, rollbacks, and monitoring for changes in your Kubernetes applications, resulting in faster delivery and fewer errors. Chapter 6. Helm Best Practices. As with any tool, there are best practices that ensure you're getting the most out of Helm without falling into common pitfalls. Version control for Helm charts. Storing your Helm charts in a version control system like Git ensures that every change to your Kubernetes resources is tracked. Handling Helm chart dependencies. How to manage complex dependencies between microservices using Helm's requirements.yaml and subcharts. Deploying to multiple environments. using Helm's ability to override values.yaml files to tailor deployments to different environments, for example, development, staging, production. Helm in multi-cluster environments, best practices for managing Helm across multiple Kubernetes clusters, including Helm File and Helm 3's new features. By following these best practices, you can make your Kubernetes deployments more maintainable and scalable, while also reducing the risk of misconfigurations. Chapter 7. Advanced Helm Features. As you gain experience with Helm, you'll encounter more advanced use cases, such as managing Helm releases across large, distributed teams or clusters. In this chapter, we delve into some of the more complex features Helm offers. Helm hooks, special annotations that allow you to hook into Helm's lifecycle to perform pre- or post-deployment tasks such as running database migrations. Helm tests, built-in support for testing your Helm charts before rolling them out to production. Helm plugins, extending Helm's functionality through plugins that can be used to Chapter 8, Helm and cloud-native ecosystems. Helm isn't just limited to Kubernetes alone. It plays a key role in the broader cloud-native ecosystem, integrating with various tools that enhance its functionality. This chapter will discuss Helm's interaction with Kubernetes operators, how Helm can be used alongside Kubernetes operators to manage more complex, stateful applications, service meshes and Helm, integrating Helm with service meshes like Istio to manage network traffic between microservices, Helm repositories, setting up and managing your own Helm chart repositories to distribute custom charts across teams and organizations. With Helm firmly rooted in the cloud-native landscape, we'll explore how you can use it as part of a larger, holistic DevOps strategy for managing cloud infrastructure and applications. Conclusion. Helm as an enabler of DevOps excellence. As we conclude this journey into Helm's role in DevOps, it's clear that Helm isn't just another tool in the Kubernetes ecosystem, it's a key enabler of modern, automated software delivery. By embracing Helm and its capabilities, you can drastically improve the efficiency of your Kubernetes deployments, enabling your DevOps team to move faster, more reliably, and with greater confidence. In a world where agility and automation are critical, Helm helps you orchestrate the complex machinery of cloud-native applications, ensuring that every release is as seamless as possible.